Hello, my pre-calculus students, and welcome to our first video lesson from home. I have a microphone here that I'm speaking into, so I hope you can all hear me clearly. Please let me know in the comments if you have any problems here with the audio, video, or anything else. Okay. Now, I am going to post this 5.5 handout, so you can either print that off from home or just get a piece of paper and write down the examples and follow along, please. Okay. We are moving on to chapter 5. Now, you might be wondering, why are we starting at 5.5? Well, we are going to go back and do some of the earlier sections in chapter 5 later, but those are a little more difficult and take a little more time to understand. I thought with our first lesson from home, we should jump into something easy here. So we're going to start with 5.5 and 5.6, which is about the law of sines and the law of cosines. These are pretty easy to understand. Now, you will need a calculator for all these problems. So these two sections involve solving triangles, okay? Which we've done so far. We've used sine, cosine, tangent to solve right triangles, but those only work, the SOHCAHTOA definition only work for right triangles. There are two other laws, one's called law of sines, one called law of cosines, that work for all triangles. It helps you solve angles and sides for any triangle. Does not have to be a right triangle. Now, the proof for where this comes from is in your book. So if you want to look, if you care to look for that, it's at the beginning of section 5.5 on page 427. But the way it works is that if you have triangle A, B, and C, okay, and opposite sides A, B, and C. And this goes back to geometry. If you remember in geometry, if you have a triangle, if that's angle A, angle B, angle C, then that's side A, side B, and side C. Okay, so for, again, any triangle, not just the right triangle. So what this is saying is that the ratio of sine of A over A is the same as the ratio of sine of B over B, which is the same as the ratio of sine of C over C. Okay, so we have three things that are equal. So really what we have is three different equations enrolled in one. You can use A with B, you can use A with C, or you can use B with C. It just depends on what you're trying to solve for at that time. Okay, so basically in any case, if you have these two, for example, there are four unknowns there, angle A, angle B, side A, side B. Anytime you know three of those four unknowns, you can solve for the fourth one. Okay, so the two you want to choose depends on what you know, what you want to find. So if you remember from geometry, there's like different ways we know triangles, the AAS or ASA. This is angle, angle, side, or angle, side, angle. Okay, so they go in order. Like if you know angle A, angle B, and side A, that'd be angle, angle, side. Or if you know angle A, side C, and angle B, that's angle, side, angle. So the first case we're going to have is if you know two angles, either angle, angle, side, or angle, side, angle. Doesn't really matter which one. Okay, so let's draw a picture. When it says solve the triangle, what it means is solve for all the missing angles and missing sides. So we know two angles and one side, so we need to know angle C, side B, and side C. Okay, so my first suggestion is to always draw a picture for triangle A, B, and C and label what you know. And make sure it's big enough so you can see what you're doing. So it doesn't matter what you call the angles, and they don't have to necessarily be proportional. So, you're, if you want, you can, try to make the largest angle look like the largest one that you drew and smallest angle look like the smallest one, but it doesn't have to be. So angle A is 36 degrees. Angle B we know is 48 degrees, and side A is 8. So I don't know side C, and I don't know side B, and I don't know angle C. Okay, so what can we find first? Well, I think it's pretty clear that anytime we know two sides of a triangle, I can find, I'm sorry, not two sides, I meant two angles. Two angles of a triangle, we can find the third angle, because we know that the three angles of a triangle must add to 180. So first thing I can find right away is angle C, right? It's just going to be, add these two and subtract from 180. So it's 180 minus the sum of 36 plus 48, okay? And you get 96 degrees. So there you go. That angle C there is 96 degrees. Okay. And again, it might not look like it in my picture, but that doesn't matter. That's 96 degrees. All right. Now we have to find side B and side C. Okay, let's find side B first. So you always, to use law of sines, you have to know one angle and one side across from each other. Either you need to know both A's, both B's, or both C's. In this case, I know angle A and I know side A. So I can start with that. I know that the sine of 36 degrees over 8 equals, and then I want to find side B, so I'm going to use angle B. The sine of 48 degrees over B. Okay, so that is my first equation there, just using A and B. Sine of A over A equals sine of B over B. Now, as I said, there's three things we know. There's one we don't know, so just use your algebra to solve for B. Okay, we can cross multiply and say B times the sine of 36 degrees equals 8 times the sine of 48 degrees, and then divide by sine of 36. So B is 8 times the sine of 48 degrees divided by the sine of 36 degrees. All right? So get out your calculator, type that all in, make sure you're in degree mode, of course, and you get B is about 10.11. Okay? And 2 decimal places is good enough for these. We're not that precise. B is about 10.11. Okay, now, we have one more side to find, side C. Okay. Now, let me pause for a moment. Do not use Pythagorean theorem. Sometimes students want to say, okay, I know two sides of a triangle. I can just use a squared plus b squared equals c squared. Remember, Pythagorean theorem only works for right triangles. Only for right triangles. This is not a right triangle. So we can't use Pythagorean theorem. But we can use law of sines again, because I know angle C, and I want to find side C, and I know angle A and side A from before. So I'm going to set up another ratio. Sine of A over A equals sine of C, which is 96, over C. And then just like I did before, I'm going to cross multiply and divide. So C is going to be 8 times the sine of 96 degrees over the sine of 36 degrees. And you get C is about 13.54. Okay? So there you go. There's the three unknowns I had to find. I found angle C, I found side B, and I found side C. So that's all we're doing here, because we're just solving triangles for all the missing sides and missing angles. Okay? And again, today's lesson is all going to be using the law of sines. Not at the back. Okay, go to page 2. Let's do another one. This is side-side angle. Okay? And you can see why we don't refer to it as angle side-side. It is side-side angle. All right. So we know two sides and one angle in this time. All right. So what do we know here? We know angle A, side A, and side B. So once again, okay, let's draw the picture. Okay. We'll call that A, that B, and that C. So we know A is 32 degrees. Side A is 6. Side B is 7. Side C is unknown. Okay. So I know side, angle. All right. So I only know one angle, so I cannot find either angle yet. Okay. So let's see. What do I know? I know angle A and side A, and I know side B. So the only thing I can find right now is angle B. That's the only thing I can find right now. Okay. So I'm going to use my law of sines again. That the sine of 32 degrees over 6 is the sine of B, which I'm trying to find, over 7. Right? So again, three things I know, one thing I want to find. Okay? So I'm going to multiply both sides by 7. Sine of B is 7 times the sine of 32 degrees over 6. Now, I have to solve for B. How do we get rid of the sine function? That's where we use the inverse sine function. And that's what a few of you forgot on your Chapter 4 test, which unfortunately I wasn't able to pass back. But some of you forgot to do that when you were solving for angles on that. So the way to get rid of the sine function is to do the inverse sine of both sides. So B is going to be the inverse sine of all that stuff on the right. Sine, 7 sine 32 degrees over 6. Okay? So just type this in your calculator, exactly like that. Inverse sine, 7 sine 32 over 6. By the way, do not round. Don't do this in multiple steps. All right? Don't type this in and get a decimal, write it down, and then do the inverse sine of that, because your answer will be off because of the rounding error. Always do this in one step. Just do inverse sine of this whole thing in your calculator, and you should get that. Angle B is approximately 38.19 degrees. 38.19. Okay. So now I know my second angle, B. Okay. Well, once I know angle B, then I can always find the third angle just by adding A and B and subtracting from 180, right? So the third angle is always the easy one to find once you know the first two. So C is about 109.81 degrees. Angle C is 109.81 degrees. Okay. So there's one more thing left to find. I know angle C. I don't know side C. So I'm going to go over here. I want to find side C. Okay. Once again, start with what you know. Sine of 32 degrees over 6 equals the sine of angle C, which is 109.81 over C. All right. And then cross multiply and divide. C is going to be 6 times the sine of 109.81 over the sine of 32. So you get about 10.65. Okay, there's your third side. All right, so recapping one more time here. We knew angle A, side A and side B. So first thing I did was use law of sines to find angle B using the inverse sine function. Once I find angle B, I can find angle C very easily. Then I can use angle C to find side C. All right, so that's all we're doing here, is just using law of sines, okay? Now, law of sines doesn't always work. If you cannot use the law of sines, we'll use law of cosines. That is the next lesson, okay? For today's homework, everything's going to be law of sines. All right. One more here. There's an application problem, number 37 from your textbook. So let me show it up here. This is on page 432. Page 432, number 37, okay? There's the picture, and you can all look in your own textbook. But you have two markers on one side of a canyon. And let me move it out of the glare here if I can. Not really. Anyways, like I said, you can look in your own textbook. Two markers on 56 feet across from each other on one side of the canyon. Angles and side C is across from it. We know that angle BAC is 72 and angle ABC is 53. It wants to know what is the distance between C and A and what is the distance between the canyon rims. In other words, what is the distance straight across there, assuming that they're parallel. All right, so I'm going to draw that picture right here. Okay, and then we can solve it. All right, so again, this was on page 432, number 37. All right, so we have our two canyon rims like this. Okay, here's A, here's B, and then here's C. All right, we know that these two are 56 apart. Okay, we know that angle A is 72 and angle B is 53. All right, and we want to find the distance across from each other. That's part B. Okay, part A has to find the distance from A to C, which we would call side B, right? Side B is across from angle B. So, part A, we have to find side B. Okay, well, what do we know? We know two angles, right? Angle A is 72 and angle B is 53. So I need to find angle C here, right? So angle C is going to be 180 minus 72 plus 53. So angle C is 55 degrees. All right, angle C is 55 degrees. All right, we need that because we know side C. All right, 56 is side C. All right, so I'm going to set up a law of sines to find B. I'm going to say that the sine of 55 degrees over 56 is equal to the sine of 53 degrees over side B. Okay, so cross multiply and divide. B is going to be 56 sine of 53 degrees over the sine of 55 degrees. All right, and B, so you can look down your calculator. B is about 54.60 feet. Okay, so that is the distance from A to C. Okay, now part B, they want us to find what I call D, the distance across straight across the rim, so perpendicular to the base, right? This is the distance perpendicular A to B. Now, be very careful. Do not make the assumption that this cuts 56 in half, okay? We mentioned that previously with the example. All right, if this is an isosceles, if we know this is isosceles, right, if these two angles are the same, then this will cut this in half. But these two angles are not the same, right? This angle is larger than this. So this side here will be larger than this. Right? It may not look that way the way you drew it, but according to these angles. So again, you can never assume that this cuts this in half. Many students make that mistake and then get the problem wrong. Okay, so we don't know this distance or this distance, but we do know this side here, side B. Okay, so I have A, but here's the thing that helps us. Look what I have here. Take away that side, you have a right triangle. Since I have a right triangle, I can use my regular SOHCAHTOA trick. I don't have to use law of sines. Now, you could use law of sines, with one of the angles being 90 degrees, or you can just set up your SOHCAHTOA, right? You want to find, 72, okay? You want to find the opposite, and the hypotenuse. So just set up a regular trig ratio. Sine of 72 is opposite over hypotenuse, and then solve for D. Multiply, D is going to be 50.6 sine of 72 degrees. And you get approximately 51.93 feet. Okay. So, that's how you solve those. So a lot of these problems are going to be application problems where you have to draw the triangle. Sometimes it's given to you, or sometimes you have to draw it yourself, but you have to draw a triangle and you have to find one or more of the sides, and then you might have to find something like this, okay? So if you get to a homework problem and you get stuck, look back at this example here. So here's what I want you to do from homework from your textbook on page 432. Number 6, 10, 25, 26, 38, and 40, okay? Now, not too many, because with these problems, as you can see, once you do a couple of them, you hopefully have the hang of it, okay? So let me kind of walk you through here in your textbook what to do. For 432. Number 6 and 10 is just, they give you, information, solve the triangle, just like the first two examples we did. Okay? 25 and 26, it gives us these triangles, okay? And it says, decide whether or not it can be solved with the law of sines. If you do have enough information, then solve it. If you do not have enough information, don't solve it. Okay, so sometimes there's not enough information given to do law of sines. Remember, to do law of sines, you have to know an angle and a side directly across from each other. Okay, so if you know that information, solve it. If you don't know it, then just say you don't know it, and then move on. Then there's two application problems, 38 and 40. Okay, so here's 38. Okay, gives you a triangle. All right, now just be careful. You don't know this angle here or this angle here, but you can figure them out, right? Because you know that this is 38 and this makes a right angle, right? Here's another right angle, and you know that angle is 53. So then you can find those two angles, right? And you know the base, and you can find the height, just like example 37 we did. And 40 is the same kind of thing here. You know that the distance between A and B is 2.32 miles. You know these two angles, you want to find the height. Now, first thing you have to do is you have to find one of these two sides. It doesn't matter which one. And you don't have to find both. You don't need both. Just find one of these two sides, and then once you find one of those sides, then you draw a right triangle and find the height of that balloon. Okay? So, once again, work on these homework problems, please. Okay? If you have any questions about what to do, you can post those on Google Classroom or send me an email. Okay? And then when you're finished with those, take a picture, please, and email it to me so I can check all your work. I will post the answers to these tomorrow, and then I'll have another video explaining 5.6 after this. Thank you. Everybody have a good day.